Hello everyone, my name is Farhah Hanani binti Mohd Nazaruddin and my supervisor is Dr. Mariam Firdhaus binti Nordin. The title for my final year project is Silica extraction from rice husk ash using water-based process. Firstly, for the introduction, the rice husks are the durable protective coatings of rice grains that are removed during the milling process from the grains. The rice husk contains around 40% cellulose, 30% lignin group and 20% of silica. The rice husk was being used as a source of raw materials for various manufacturing applications. According to Chandrasekhar et al. 2003, the high silica content in rice husk gives it a better potential source for silicon-based materials. Next, according to Amuta et al., more than 80% of the silica and a low percentage of impurities such as potassium oxide, sodium oxide, and ferrum oxide are found in the rice husk ash. The rice husk ash is the outcome of the rice husk incineration. Amongst all plant residues, it has the highest percentage of silica materials. The features of the ash are based mostly on the composition, burning temperature, and burning time of the rice husks. Silica is also known as particles of silicon dioxide. Next, amorphous silica is the main component of the ash, under controlled combustion burning temperatures in the range of 500 to 700 degrees Celsius for a period of about 1 hour. The silica can be obtained easily from the extraction process. A previous study shows that the extraction process usually is carried out by using acid and alkaline solvents. It is a basic raw material and due to its special properties, silica has had an irreversible impact on healthcare, physics, chemistry, biology as well as other industries. It is also used in the pharmaceutical industry. Extraction is the first step to separate the desired natural products from the raw materials. It is a process in which one or more components are separated selectively from a liquid or solid mixture. The term washing may also be used to refer to an extraction in which impurities are extracted from the solvent containing the desired compound. In the extraction process, a chemical mass transfer from one process to another is often involved. The figure below shows the solid-liquid separation process. Subcritical water extraction is a green new technique for a shorter production time. It will achieve better extraction and hydrolysis if using this method. The subcritical water extraction uses a great method to maintain the water in a liquid phase. According to Tian et al., if you use a shorter time, it has a less effective extraction process, while the degradation of bioactive compounds to be extracted if you use a long time. Most high solubility in water is extracted at a low temperature by Smith 2006. Almost all of the previous studies used rice husk ash to produce amorphous silica as their raw material. During the research of this project, more than 80% of silica and a low percentage of impurities are found in the rice husk ash which could be extracted by acid leaching. Furthermore, high thermal and chemical approaches have also contributed to some bad environmental consequences. This project will give an approach to the procedure of the water-based extraction process for the rice husk ash to produce silica. New techniques such as subcritical water extraction are being applied. It is to minimize the use of organic solvent and enhance the extraction process of the constituents of plant materials. It is therefore important to idealize a solution that is low cost and environmentally sustainable for the industrial applications. Firstly, to conduct the extraction process by using green new technology such as subcritical water extraction system from the rice husk ash to silica. The silica will be extracted from the rice husk ash by using a subcritical water extraction process. The optimal condition can be examined by using different times and different heating temperatures. The extraction method has been designed using the design of expert to define the combination of the two factors in the one response that optimizes the extraction phase using the RSM. Next, it is to identify the characterization of the extracted products by using the Fourier transform infrared spectroscopy unit. The characterization of the silica bonding will be reviewed by using past articles or papers that use the FTIR spectroscopy unit to characterize their extracted products. It will be shown the presence of silica functional groups from the extracted products. Lastly is to review the comparison of water-based process with SOXHLET extraction. The articles for SOXHLET extraction process will be compared with the water-based process. It is to show the comparison of the optimum condition and the best solvent in the SOXHLET extraction. Firstly, 75 grams of rice husk ash will be used in this experiment with 13 runs. Next, 1.5 liter of distilled water for each runs. And lastly, pilot scale of the subcritical water extraction system will be used. All extraction are carried out using a 5-liter stainless steel cell. 75 grams of rice husk ash is filled in the extractor. Next, transfer 1.5 liter of distilled water into the extractor. Then, heat up to 160 degrees Celsius and maintain at that temperature and start the extraction for 20 minutes. Use different temperatures and time based on the RSM. Then, it will transfer to the collector automatically and the residue in the extractor is recovered with the aid of nitrogen gas. Then, collect the extracts when it is cool. The collected extracts are stored at 4 degrees Celsius for use in the subsequent experiments. The procedure will be repeated by using different conditions. For the methodology of the other objective, firstly, identify the information by making a critical analysis of the FTIR analysis and SOXHLET extraction process. Next is by summarizing and evaluating the information of the past articles. And lastly, by making a comparison for the optimum condition of FTIR analysis and SOXHLET extraction process on the previous articles. Next, for the results and discussion, the yield of the extraction products is calculated by using the equation and based on the data for the extracted products, where standard solution with a concentration of 0.05 gram per milliliter and a weight sample of 75 gram for every experiment are prepared. Based on the table, 180 degrees Celsius and 30 minutes were found to be the optimum condition for the heating temperature and extraction time. Under the optimum condition, the silica yield was 96.67%, which is the highest among the other conditions. The figure showed the silica extracts that have been collected in the experiments during the optimum condition. This table shows the critical review of the subcritical water extraction process. Most of the articles shows that the optimal extraction condition for the plants that could be extracted for the best yield was within the temperature range of 125 to 220 degrees Celsius and the extraction time range of 10 to 30 minutes. Based on the current literature, pressure has a lesser impact on solvent properties. It is because water is incompressible below 200 degrees Celsius and there is no visible influence of pressure on the physical characteristic of the liquid state. Next, this table shows the critical review of FTIR analysis. FTIR is an efficient analytical method for functional group identification and covalent bonding knowledge characterization. The finding shows that the silica more obtains at the combustion method rather than the chemical method. This finding, which indicate the existence of nanosilica, are consistent with those published in FTIR analysis literature. Though there are minor differences in peak locations, the highest peak matched those found in the previous study, indicating the existence of nanostructure of silica. This table shows the critical review of the SOXHLET extraction process. In this review, it is concluded that solvent selection is important for the extraction process. Methanol was selected as the best solvent for the extraction process based on the findings. The heating effect on the extraction method may contribute to the methanol solvent evaporation process that will leach out the substance of the extracts. Most of the SOXHLET extraction process consume a lot of time, which is more than 3 hours for every extraction process. For conclusion, firstly, the extraction temperature is one of the most significant parameters influencing subcritical water extraction efficiencies. This method must be performed at the maximum acceptable temperature. It should be noted that increasing the temperature of the extraction above a certain value results in the deterioration of the plant materials. Next, the extraction time gives a significant result to the yield of amorphous silica. The results show from the previous study, by considering the length for the extraction period, the yield of the amorphous silica also improved. A shorter extraction time will lead to a less successful extraction procedure, whereas the longer extraction times will lead to the degradation of the bioactive compounds to be extracted. Next, FTIR analysis will show a wave number that has the presence of silica, which shows the siloxane bond in the nanosilica from the rice ash. The silica products in the range of 1,300 to 1,000 per centimeter have a prominent band corresponding to the siloxane bond asymmetric extension. It also concludes that an open burning method has the highest peak of the presence of the siloxane bonds, which is the silica from the rice ash. Lastly, it was reported that extraction time is longer for the SOXHLET extraction process compared to the subcritical water extraction process. The extraction time could be decreased to less than an hour compared to conventional methods, which can require up to 8 hours for the SOXHLET extraction. Thank you for your kind consideration of my presentation.